Good morning, everyone. My name is Sebastiaan Mestdagh. I'm from the Marine Biology Department at Scheldt University. I'm going to talk about the spatio-temporal variation in the contribution of both biodiversity and the environment to the benthic ecosystem functioning in the estuary of the Scheldt. Now, the Scheldt estuary is an estuary here in Belgium and the Netherlands, located there. I studied the spatial variability, which means salinity gradients, both the polyhaline part, the mesohaline part, and the oligohaline part. And within each salinity zone, we also selected a few different habitat types, subtidal site and two intertidal sites, one high dynamic and one low dynamic. We did that every season. We went sampling for subtidal samples with research vessels in Australia, for the intertidal sample just on foot on the intertidal flats. We brought cores to the lab, we incubated them there under ambient temperature and salinity. And then we measure a whole bunch of things, which benthic fluxes for oxygen and nutrients, bioirrigation, so the movement of water into the sediment, bioturbation, the movement of sediment particles, and a whole deal of abiotic and biotic variables. With these data, we did a redundancy analysis where we modeled functioning as a multivariate response composed of benthic fluxes, predicted by all the other biotic and abiotic variables that we measured. And the result looks a bit like this, where mostly temperature and species richness come out as important predictors to the variability in ecosystem functioning. The dB you see on the right is bioturbation, plays also a little role here. If you look more closely at the cloud of data points, then you see that there is a very nice spread along the vertical axis, so according to temperature. It should not be very surprising that these are the different seasons. So September is located there, December there, March there and there, and June in the corner up there. You also see, especially for September and December, that there is a gradient from smaller to bigger symbols like this, which corresponds to the salinity zones. But then to see what the contribution is of the biotic or the abiotic factors to the variability in the model, we did variation partitioning. We calculated the amount or the percentage of variability that's explained by abiotics and by biotics, and the result is that apparently biotics here explain much more of the variability in ecosystem functioning than abiotics. But the overall power of the model is less than 20%, so it's not very strong. And if we make subsets of the data set, we often get much better results. For example, if we look at the different habitat types, we get these results for low dynamic habitats, these for the high dynamic, and these for the subtidal samples. In subtidal samples, there were hardly any animals, so abiotics is the only thing that counts. But for the other, the intertidal habitats, you see that the total variability explained by the model is already up 10% compared to when we took the entire data set. And you see there's some variability in the particular biotic or abiotic variables that explain variability in the model. Sometimes it's species richness, sometimes bioirrigation, sometimes bioturbation. Look at the different seasons, we see something similar. There's also quite some variability in what really explains the variability. In September it's only biotic, in March it's mostly abiotic, but there's quite some variability overall. This research is still ongoing. Instead of looking at species richness, so the amount of species there, maybe we also want to look at the densities of the functional groups, so which species are there. But so far, we can already say that both biodiversity and biotic processes, so bioirrigation Bioturbation play a role, and there's spatial and temporal information. Thank you.